This problem asks us to find VB using nodal analysis. Okay, and then I'll throw in I of 3 as well. We want to find I of 3 as well, which is right here. Okay, so using our nodal analysis, we see that we have a point here that we want to find. And our first step is going to be coming over here and writing out our KCL. So I1 coming in, I2 coming in, then I3 leaving. So your equation can be I1 plus I2 minus I3 is equal to 0, or it can be negative I1 minus I2 minus or plus I3 is equal to 0. Up to you. Okay. Something else that we're going to need is a ground, a reference voltage. So V of G is going to be equal to 0 volts. And we need to pick a point on the circuit for that would be most advantageous for us to place a ground, to have a reference voltage. And we notice along here, all three of those branches connect or have some sort of connection to that bottom wire. So we can just go ahead and assume that that's a good location for it. Okay. So now that we have that, let's go ahead and write out our equation. So for I1, we can write negative V of A minus V of B over 10 ohms. Then for I2, we can write negative V of C minus V of B over 20 ohms. And then for I of 3, we can write plus V of B minus V of G over 40 ohms. And that'll be equal to 0. Okay, so all we need to do now is come in here and plug in some values. So we know that here this is 0. This will be 0, this will be 0, this will be 0, 0, 0, up until we hit this 10-volt battery. Then we'll pick up 10, we'll pick up 10, and then V of A will be 10 volts up until it passes through this resistor. Same deal over here, 0, 0, 0, pass through this 20, 20, 20 until it passes through that resistor. Okay, so let's just go ahead and plug in these values. So we'll do negative V of A, we said was 10 minus V of B over 10 minus V of C, we said was 20 minus V of B over 20 plus V of B minus 0, the ground is 0, over 40. And that is equal to 0. Okay, and to simplify some of this, what I'm going to do is multiply this entire thing by 40 by a common denominator. So here we'll get negative 4, 10 minus V of B minus 2 times 20 minus V of B, then plus V of B, and that'll be equal to 0. Okay, so now we just need to combine like terms. And combining like terms, let's see, well, let's actually factor out real quick. So we'll get negative 40 plus 4V of B. We'll get negative 40 plus 2V of B, and then plus V of B, and that'll be equal to 0. So this looks like 4, 6, 7, so 7 V of B is equal to 40, 40, 80 is equal to 80. So therefore, V of B is going to be equal to 80 over 7 volts, which is roughly 11.43 volts. Okay. So now let's find what I3 is. So I3 is going to be equal to, it's going to be V of B minus V of ground over that 40 ohms. And just real quick, this is I1, this is I2, and this is I3. So we now know what V of B is. It's 11.43 minus 0 volts over 40 ohms. Therefore, 0.286 amps is I of 3. Okay, and that's just a real quick nodal analysis problem.